I'm Raniel.
I'm Duran. In today's episode of the Raniel and Duran podcast show, we're going to be examining how we can leverage an integrated development environment, or IDE, to help us perform code reviews. In this particular example, we're looking at the super vulnerable Java application. We'll also look at another piece of software that we have decompiled, and what we're going to try to do is see if we can't use the IDE to help guide our code examination process. And I'll tell you really quickly, one of the most important things with something like this is we have to recognize that how we do this is going to vary based on the maturity of the software, the maturity of the development team, how secure, how well they write code. You'll also find that as a team becomes more secure, we're actually going to look at more things. But initially, it's going to be a fairly broad code coverage, fairly broad scan. So to do this, in our particular case, we're actually going to use code inspect. And this is IDEA's version. You'll see that tools like Visual Studio, Eclipse, etc. all have a similar tool as this. My preference is actually to use Rigour if I'm working C#, C-Line if I'm working C, C++, use IDEA if I'm working something like Java. They have, of course, PyCharm, etc. And part of the reason why I use the IntelliJ platform for this kind of activity is it has large language support, but it also has considerably better inspection capabilities than Eclipse or than Visual Studio or Visual Code or any of those other tools. Really quickly, before I walk too far into this, we'll take a gander at our actual inspection. You'll notice that for this exercise, I'm running a lot of checks that I would not normally run. And I'm doing that mostly because I'm showing you if I knew nothing about the system, if I didn't know what was on it, if I didn't know anything about it, maybe I would run some of these others. But the truth is, typically you examine at least a little bit. The other thing is IDEA, writer, etc. will tell you the kinds of things that you're going to be dealing with. They'll tell you if the struts framework is detected, if Spring is detected, if SAS is detected, if all of this other stuff. So it will actually walk you through a lot of that process, and then you can adjust these inspections accordingly. All of these are checked right now because this is my default, which is junk. It's not something I would actually normally use, but everything is checked in it. This I only exclusively use for demonstrations. There's no reason why you need all of this stuff checked. Definitely you'd want to do it on a per project basis and uncheck things that simply aren't used in the environment in question. One thing you will maybe notice is that I do have a lot of the Java-based inspections checked. Now, that's actually on purpose, and a lot of these you might find strange. But again, our big goal here is to find code that doesn't seem right. Code where maybe I should look a little more. So we would look for various visibility issues. We would look for things like a local variable hiding a field, a local variable hiding a class variable, anything of that nature, a local method that is overriding another method but in a strange way. If we have any strange inheritance going on, if we have subclasses calling to parent class variables in an odd way, things of that nature. This also does a really good job at looking for serialization, synchronization issues, and it lets you know a variety of security vulnerabilities and things of that nature. But enough of that. Let's actually get to it. We're going to hit analyze, and this will take just a minute. So we can see we've already got results back. It's going to finish propagating all of this. There's going to be a lot in it, mostly because we have everything checked. I definitely wouldn't run like this normally. However, I want to point out really quickly before we go anywhere, one of the great things about IDEA is if you have a Maven project or if you have something like that where you have this central repository and you have various libraries, it will actually run scans against what you're calling to, looking for vulnerabilities, known vulnerabilities in the libraries or in the calls, but it also looks for unsafe calls or calls that generally aren't a great idea. Like what we see here where it's complaining that we have this base 64, decode base 64, and it explains in this that we're talking about using a vulnerable API, and what we should do is update the version in this particular case. You'll also see here, it's run through our Maven file and it's already reported, hey, you need to go through and update each one of these libraries. And we can see log4j, Apache Maven, Apache Struts. And it actually allows you to see what the vulnerability data is for these. It'll list out all the CVEs tied to it and data like that. So this is actually very nice little tiny add-on. Yes, we can get this through our SAS tools. We could get this through looking up each one of these versions ourselves, or we could just use the tool. Rigour does something similar. You'll see similar activities with some of the other IDEs. You don't get as much of this power from IDEs like Visual Studio. So moving on, if I were looking at code that I didn't know well, I would definitely start looking at some of these visibility issues. I'd definitely take a peek at some of these other issues in here. 100%, you know I'm going to be looking at these security issues. And what I really want to know here is we have this public static collection field. The reason why it's complaining about public static collection fields is, as it says right here, these are bad because even though it's marked final, it's mutable in almost all cases. So the question now becomes, I, as someone who's reading this code, I need to verify that they are not using an immutable map, an immutable collection. The truth is, by default, if you're talking C#, if you're talking Java, if you're talking Perl, Python, etc., these structures are mutable. What that winds up meaning is that we can have race conditions introduced, but we also have a variety of other vulnerabilities that can be introduced as a direct result. But the most frequent vulnerability that we have from something like this would be tied to race conditions, starvation, deadlock, live lock, and things of that nature. So what we actually would want to do is let's take a peek at the actual code. And what we see here is they have a new enum map. So we know this structure, such as it is right now, it would be vulnerable. Someone can modify the data inside of the new enum map. We also know we have this file type category, and we would want to know whether or not that structure is immutable. If this structure itself is immutable, then it's not a big deal. We know, of course, since this is an enum map, that we don't have to worry about that. But this list here is mutable, and we'll get to that here in a second. So looking at this, we see all of our puts, and I want to concentrate on this little bit right here of code, the collections.unmodifiable map. So what this is going to do is this is going to guarantee that our map is in and of itself immutable. No one can add and no one can remove items from the map. We still have a question of the data types contained within this map. So file type category, we know that's good to go. But these individual lists of strings, now we know strings are immutable. What's not immutable are these lists. So we now have to ask, well, how are they making these lists? And we can see we're doing list.of. As you see from the Java doc right here, it says list.of returns an immutable list. So we know that for this entry, this value is immutable. We also know the key is immutable. We know the same actually for each one of these. Now, if they had created a new list, be it a new array list, a new linked list, a vector, doesn't really matter. If they had created a new list or a new collection of some kind and put it inside this map, we'd have to do the same exercise for that list. And what that really winds up meaning is that for any of the data types inside of our collections or maps, we need to verify that those data types are themselves immutable, because what we don't want is a race condition because this is public static. We can't have any of that. So let's look at the next example. In this particular case, we see it's a map of two strings. So really, I can just zoom ahead in this to what's returned. Or you'd think I could zoom ahead to what's returned. We'll get to that in a second. So looking, we have this map of entries. This again returns an unmodifiable or immutable map. If someone tries to add something to it, remove something from it, or clear the map, it's going to throw an exception. So we know that this is good to go. This is perfectly fine. This is actually safe. The thing that I find interesting is this code block right here. When I look at this code block, I'm going to ask, why are they doing this? So I'm going to check the usage here. We see that this is a public static final. We see it returns this guy right here. So why are they doing this check? And the answer is, it would seem anyway, at least on the surface of it, that this is probably a method that used to be public or protected, default, something other than what it is today. It probably was a member of maybe some other library or some other call, and what they were worried about was someone calling something that's already been set. They don't want to incur the computational cost of having to recreate this map over and over and over again. Is this harmful? No. Does it do anything? Not really. A couple of really quick things. And I mentioned really briefly that there are a lot of checks that we will add over time. And many of those checks involve things like design for extension, which is what we see here. Or they are things like serializable class in a secure context. I cannot stress this enough. Everything we do has to be commensurate with the data and the security requirements that the data has. We need to ensure that our level of rigor is commensurate with the data's security requirements. This also means we need to incrementally move a project or a program forward. That is going to involve slowly but surely ratcheting up what we're looking for, slowly but surely increasing the things that we're checking when we do a longer term engagement. And these are actually preferable to how most organizations do it today. Today, you'll see maybe an annual check, or maybe it's every quarter or what have you, where someone's doing a code scan or something of this nature. Obviously, that's not ideal. The best thing would be to have a security liaison, which we talk about in a prior episode, or something of that sort, where we have people embedded who are constantly running scans like this and constantly working with these development teams to help ensure their security. As part of that process, what they are doing is slowly but surely, as they educate the development team and as they help make improvements to the code base, they're adjusting the code so that it's more secure and they're actually increasing what they are looking for. Some of that is going to be tied to what we see here inside of the serializable class in a secure context. Some of that is also going to be tied to other things that we simply don't have checked at the moment. So do be aware that over time, we are going to check more and more and more things. Design for extension, for example, this is a big deal when we talk about a more secure system where we are afraid that someone might drop a jar, or we are afraid that someone may nefariously add classes or extend something that we don't expect them to extend. that we don't expect them to override, and so we aren't properly protecting our code. That is what this is all about. And these are the kinds of things that you would add in a more mature system with a more mature security posture. Another thing that's really important that we're just going to glance at, just again to give you a flavor, to give you these different examples of how we can use this tool to help us find vulnerable code, or to help us find locations with suspicious, suspect, buggy, and or vulnerable code. So it may not point directly to the vulnerable code, and that's really important, but it may instead point us to an area that needs a little more attention, a little more scrutiny. So when we look at this particular one, the auto-closable used without try with resources. What we're most interested in is how are they closing these, since they aren't managing it with the try with resources. That means they need to be managing it themselves. And most systems do this wrong. Most systems do this horribly, horribly wrong. Looking in this particular example, we have this right context get builder. This returns a connection. What we notice is there's no closing of this context, but that's not what this is keying in on at the moment. It's actually keying in on our line right here, right context, insert query. And we can see that when we look at the code down here. We have to understand what's going on in this particular API that is causing this finding. And we can actually, of course, use a tool like IntelliJ to automatically decompile the library and show us what this code is, so we can get a good idea. And we see, of course, this is DSL context. This happens to just be a stub. We can look at the particular implementation if we so choose. So looking at this, we can see that it's going to be returning a new insert query. And when we look at this, we can see this calls to super. It sets a few different variables, and these are important because this is where your resources are being allocated. And this is maybe why the developers who made this particular library, which by the way, I've mentioned it once before, but Juke is a phenomenal tool. If you're working with Java, definitely I recommend use Juke if you have a backend component. It will make your life so much easier. It will make it so you are free from the database type, be it Postgres, be it MySQL, be it Microsoft SQL, whatever it happens to be, Oracle. It supports a large swath of databases, and it makes it so we can write good, clean, secure, consistent code that connects to those databases, that escapes everything as appropriate, that uses parameterized queries, that isn't going to be vulnerable to SQL injection, and that I can swap out that backend ad nauseum, ad infinitum, without any fear that by doing so, I'm opening my system up to insecurities or inefficiencies. It's actually really, really nice. So having glanced through that, I'll tell you, I'm actually not concerned with the fact that this particular statement isn't using try with resources. I understand that insert query is auto-closable. The reason why it's auto-closable is because they are using a parameterized statement. But I also already know that in later versions of Juke, they no longer require this particular thing to be auto-closable, and that this is an artifact of it being a very specific version. So I'm going to give this one a pass. Looking here, we have this ctx query.getSQL, and this again is what's complaining that we have this auto-closable and we're not releasing it as part of that auto-closable. I happen to again know the API involved. I happen to also know, based on this API, and we can see here it's this .query that's causing it. I have no concerns here. It's actually being closed later on just as part of what Juke does. So that's not a big deal. And I see it again here in this select query. So we've seen that in each of these three examples, it's not a big deal and it's not something I'm going to worry about. I don't need to worry about leaky memory or anything of that nature. And that's really what we're concerned with here, memory leaks. Now, we can see this warning about the driver manager. In this particular case, we're using an older it's an older system, it's using an older library. Their suggestion is that you use the Java X version because it better supports pools and things of that nature. And we can see that right here in the description from IDEA. That's fantastic. This is older software. Actually, this is purposely older software, purposely vulnerable software. It's not something I'm going to mention. I will tell you though, when you are on an engagement, if you work with the customer and you get to understand them, one of the best things you can actually do is point out tiny, easy wins like this. So this wouldn't be a vulnerability because it's not. It would be a best practice where you say to them, hey, if you can, try swapping your java.sql.driver manager out with javax.sql.data source, and you'll get a performance increase. You'll allow connection pooling. It's going to be a little more modern. It'll feel a little better. It'll be a little easier. But this may not mean anything if they're using something like Hikari already or C3PO or what have you. But at least you're able to call it out and say, hey, guess what? There's more modern tooling out there we can use. It's an easy win. It's not a real difficult thing. You're already using Maven. You can easily swap over your packages, and the integration is already there. So that actually makes a lot of development teams really happy. It lets them know that you're there not to make them look bad, but you're there to help them and help improve the quality of the software, which is really our ultimate goal. That's one of the reasons why you won't hear me run around saying, oh yeah, I destroyed this system or anything like that, because as much as I enjoy going through and doing what I do and compromising systems, in the end, my real goal, our real goal, is to improve the quality of their product. I will tell you the probable bugs, performance, portability, some of the numeric issues, memory, the language level migration aids, areas like that are actually some of the best areas to hunt for bugs, to hunt for vulnerabilities, and to hunt for suspicious code that might contain bugs and vulnerabilities. Now, you're actually going to find in this particular code, I mentioned earlier, the super vulnerable Java application is a terrible system to really do this example with, from the standpoint of, by and large, it's relatively well written. Most of what you're going to see come up from a scan like this, unfortunately, with this particular product, it's not going to have very much that's going to be earth-shattering. Although, we still have to go through and see, because, you know, there are things that are purposely in there, and this isn't something that I've actually walked through with this. I just happen to know the general performance. Now, what I would do with the more mature product like this is I would actually ratchet it down. I would check more things, and I would have it do deeper inspection. We're just not doing that because then you start getting into things much more complex discussions, much more complex ideas, and that's not the point and purpose of this video. This is really just showcasing how you can use them to help you. I want to give you an interesting example, and in this particular case, we're looking at this temporary file input stream. We see here it says result of file.delete is ignored. It's talking about this call right here, this.file.delete, where we're not checking to see whether or not it worked. We just, after we call it, we set file equal to null and pretend like everything is good. Now, when you see something like this, we have to ask ourselves, how is this file created? We should also point out, and this should be a best practice, this should be doing an if statement. It should be saying, hey, if this deletion didn't work, then I want to log that it didn't work, just to make sure that developers know something didn't work, so we can investigate any permissions issues, but also so we know what files should have been deleted but weren't, so that the system administrator, as part of their daily routine or what have you, can clean house when they're supposed to. So one of the things that we're interested in with something like this is, since it says temporary file input stream, I'm a little curious because I see them calling specifically to delete. When they're making this temporary file, they don't seem to be setting the flag that will have it automatically delete when the application is closed. It's actually concerning. I want to see what the usage is on this. And of course, I can see it doesn't look like it's being used at all so far. I find this concerning. And the reason why this would be concerning, and it would definitely be something that we call out, is because we have this class hanging out here. This class isn't being used, so maybe it's defunct code, maybe it's older code, it's probably not being maintained, or maybe it's code that hasn't been vetted yet. So I would wonder if this were in production, why is this here? And we know from our insecure deserialization and our insecure reflection videos that this kind of thing is bad because we can still call this code. This is public and it's something that can be very easily created. So I actually would have a lot of concerns about this, and this is something that we found only because we noticed that the result of the method is being ignored. And that's one of the big reminders here, is what we're after with this kind of tool is point me to areas where people are doing funny things. We of course see the same behavior here from Excel out. This tells me that this is a more common issue, and it's probably an issue with their coding standards. This is something, maybe it's a lack of education, maybe they don't know, maybe they don't care, what have you, but this is definitely something that I would bring to the attention of the development team, that they really need to be examining what happens if the file isn't in fact deleted, and why are we not caring? It could very well be that they come back and say, hey, you know what, that's nice, I don't care if this gets deleted. Alternatively, it could be the very, very thing. Some other really easy wins involve the auto boxing and auto unboxing, and this really comes down to the way the virtual machine in this case does caching with auto boxed and auto unboxed data, especially when we're talking about anything that's a number. So your longs, integers, ints, float, double, double. So your longs, integers, floats, things of that nature, int as well, all the primitives versus the objects. The reason why we care about this is because within Java and other languages, auto boxing and auto unboxing can cause problems when we're doing comparisons between different values. If, for example, we have an int that is auto boxed into an integer and we're checking it against another integer, then we can actually wind up having that comparison not properly operate because of the auto boxing, or conversely because of the auto unboxing. Another thing that I've seen actually with great regularity is people doing null checks against something that's auto boxed, because of course it can never be null. If it's being auto boxed, there's no possible way it can be null, because when that primitive is turned into an object, the primitive will always exist. But the language itself will automatically handle that in the background, and a developer may have made a change to a data type, and that's one of the key things here, and not change the corresponding code that uses it. And by not changing that corresponding code, they may have accidentally created situations that can simply never happen. So now you have entire branches, code branches, that will never get executed, all because of a bug. And that's one of the beautiful things here, is we can find bugs through this. We can also find vulnerabilities, like I mentioned, the caching, for example, where it could be they're doing a comparison and maybe it's a permissions check, and they're taking a primitive number, converting it to an object number, and as part of that comparison, they wind up actually losing the comparison itself. Alternatively, it may auto unbox, and because of caching, they get the wrong answers. So the conditional winds up either passing or failing inappropriately due to the auto boxing and unboxing. Now, the next two easy examples that we can actually look at involve string builder and collections that lack, and of course it can be a map or array list or what have you, that lack an initial capacity. This is a problem in C# and Java and a number of different languages, and it's because a lot of people don't understand the exponential growth that these particular languages undertake when a capacity is not set, and then that they take every single time that it reaches that capacity and it needs to grow. that exponential growth gives a lot of room for denial of service attacks. We strongly advise and advocate that development teams actually assess any dynamic structure like this that's going to grow as it needs to, and try to come up with a minimum, maximum, and then an average. And then using that data, they can determine what value they want to set it to, such that they don't get the thrashing from having to constantly allocate and reallocate memory as the case may be, which of course leaves a lot of junk on the heap, which then can cause problems and make denial of service pretty trivial. This is actually a problem that I have seen happen in the real world, where people did not in fact have an initial capacity and it brought the system to its knees. It's definitely an easy one to look at. Again, in most cases, it wind up being a best practice or something relatively weak and minimal. If you get code like this, I would definitely, when I see something weird like this, I start to ask why. Why is this code doing this thing that it's doing? And that's actually going to be the case with most of the things that pop here. Is it safe? Is it secure? Is it buggy? But also why? What happened that caused this to occur? Why are we multiplying by 1? That multiplication is absolutely truly pointless. Now, some developers will point out, of course, that a good compiler is going to actually remove this because it's going to recognize that, hey, this is going to do nothing, but that actually doesn't do anything for us, because our real issue isn't, hey, is this code optimal? Our issue is, how did it get this way? What happened? Was this intentional? Did someone mess up? Will this result in something bad happening? So with something like this, I'd actually start assessing the entire code and try to determine what occurred here and whether or not we care. It may very well be that it's just something that we mentioned to the development team verbally. Definitely wouldn't include this particular instance in any kind of a report. But again, development teams actually tend to be very receptive when you have these kinds of things, especially when you can have an intelligent argument, or an intelligent discussion, I should say, with that development team about what it is they're doing and why it's not good. Usually they'll right off the bat go, oh man, I made a mistake, or this is old, Johnny over there just, who knows what he was thinking. Thanks for the catch. The nice thing about that kind of thing is it also shows that you're paying attention. The method metrics, like class metrics, are actually really, really good. This winds up telling me methods and things of that nature that have cyclomatic complexities that I should look into. Why is this method so complicated? Because complex code is code that is hard to read, is code that is likely not going to be maintained, is code that is likely buggy today, and if not buggy today, maybe buggy tomorrow, is code that may cause bugs because people don't understand it, they don't know how to use it, and so they're misusing it, etc. Complex code is code to look at. Plain and simple. For something like this, I'm going to start looking at this code and saying, why is this so complicated and does it need to be? And if we really want a good example, we'd look for something like this. Secretly call action. This has a cyclomatic complexity of 28, which is pretty high. Looking at secretly call action, I mean, we can look at this Java doc real quickly. It says it's supposed to call the desired action in a cryptographically secure manner. When I start seeing that, I'm going to be interested anyway, because hey, look at this. You're doing cryptography. All right. Well, I want to see. You say it's going to be secure. Let's actually take a peek at that. So right off the bat, I see this find and load the class. I see us decrypt the action name, and then we immediately set our variable action name based on this. It's not doing any checks there. Here we check to see if action name is empty. If it's empty, then we just return an empty string. Otherwise, it does a concatenation right here. Okay, so right off the bat, I mean, my ears are now we have reflection. It's just basic concatenation. This is bad. This is insecure reflection. This is going to get my ire. This is going to get my ire because now I am immediately concerned that people can execute and call to arbitrary classes at the very least within local.rdps.svga.action. And that's actually not true. They can call into other ones too if they know what they're doing. But even an attacker who doesn't know what they're doing, they can at least call into subclasses, subpackages in the associated classes, and so on down the stack. So this is bad. And this again is that cyclomatic complexity. That's the trigger for me as a reviewer. Why is this so complicated? I'm looking at it and I'm going, I can see where this is going. We're doing heavy reflection. This heavy reflection is why this method is so complicated. And we can already see they didn't do it right. So it's complicated. They didn't do it right. That's common. And no one is going to be able to maintain this. They're not going to understand. We have these, why is it bound to local.rdps.svga.action? Why isn't it bound to something else? Well, it says desired action. Okay, well, what if someone puts action somewhere else? Now someone's going to maintain this. If I put an action outside of .action, now they have to remove that. So now it would open it up even further, even to an unsophisticated actor. So definitely, like I said, my ire is up. I'm going through, I'm already in torrent mode. I'm just absolutely loving what I'm seeing from someone who's trying to find findings perspective and crying about what I'm seeing as someone who's trying to help secure a system. Looking at this, I can see again, I mean, right off the bat, over and over again, they're beating me in the face with, this is really complicated code, trying to do really complicated things, and they're not doing it well, they're not doing it right. And just these ugly try catches going on here. I mean, it's better than it could be. It's better than I've seen a lot of systems do, but it's still not great. We see again they're doing that same thing. So they take these parameters, all they're doing for validation of any kind is making sure that this thing isn't empty, making sure that it's not null. And now they're going to loop through those parameters and decrypt the different components of it and do the world's ugliest, most computationally expensive method as they try to figure out what the person's trying to invoke. And then we get to this, which we're going to look at later because it's going to come up again. But I'm looking at this and I'm going, your code is complicated, your code is buggy, your code is insecure because of the reflection up here, your code is insecure because of the reflection down here, your code is insecure. So this found us code that you don't want to see as someone who's trying to secure a system. As someone who's doing a penetration test and you want a beautiful finding where you can, brag to all your friends about this silly thing you've done, yeah, you're going to go through and say, hey, look at this. But beyond that, it's not really great. All right, some of the other ones, of course, we would want to look at the memory components and things like that. We can see it's hitting on these static collections, and it's hitting on static collections because, of course, collections are big. It's also hitting on these collections because collections are mutable. It's hitting on these collections because being static, it's shared across all of these threads. It's shared forever. It doesn't go away. So long as this thing has been created, this object, not this instance, this object has been created because someone has created an instance or they've called the class in some way, shape, or form. These collections will be made and they will sit there forever. So it's pretty heavy. It's good stuff. The zero length array allocations, you have these anonymous inner classes, a lot of things here. Reading through the issues it has with JavaDoc can also be really elucidating, incredibly important. The Java Bean ones obviously can be great. The language level migrations, like string buffer, yeah, I would definitely tell them, hey, you should make this string builder. There's no reason why you're incurring the cost that string buffer has because of all the synchronization that string buffer does. And string buffer is insecure in a multi-threaded or multi-process environment anyway. It's just not great to use. They should switch this over to string builder, but you know, that's just a nice to have. I do really like to look at these prohibitive exceptions being declared, prohibitive exceptions being thrown. These are great. There's you would want to look at why they're throwing runtime and whether or not it's appropriate. Uh, in most cases, people are throwing exceptions with what it complains about here. So they're throwing exception, for example, or runtime exception, and that's wildly inappropriate. Your exceptions, first of all, throwing runtime is just dangerous because your compiler won't warn you. But if you're throwing exception in general, that's always the wrong answer. It's always the wrong answer. When I see something like protected fields or default fields, public fields, and again, they're mutable, I'm looking at race conditions. It's really what we're most interested in a case like this. So these would be definitely something that I would give a ridiculous amount of scrutiny to, just checking to make sure that they're doing all of this in a safe manner. I know since it's protected that it's going to be getting called by the other action classes. And the question then is it being done in a safe manner? Are you setting it before it's getting called? And of course, how are you properly accessing this? Unqualified static access. So I'm looking at this. We have file VO. It has get file here. It returns a file. I'm looking at this and I'm going, why is file static? This is a non-static method. File shouldn't be static. This is an error. That's exactly what I'm going to think. And I'm also going to say, wait. Not only is it an error, but you can see here, someone has either had their IDE automatically slap in that qualifier ahead of time or some such, or they didn't realize that this was an error. They truly thought that this was proper, but why am I calling to this static inside of a non-static context? This is an actual race condition. And this, because I can look up here at file here, not only is this a race condition, and you see we of course have added this in here, this is a race condition that leads to access control violations. Because if someone goes through, if I have two different users, one hits, they call to grab a file. It does permissions checks. It verifies that I have permission. The next user hits. They call to grab a different file. It checks the user's permissions. Now, the first one returns. When it returns, it's not returning the file that user A thought that they were getting. It's returning user B's file, which user A may not have access to. But even if they did have access to, it's not the file that user A had expected. So you have a vulnerability and you have a bug. Now, on top of that, there's another vulnerability from this. And that is best illustrated through the insecure reflection or through insecure deserialization, in either one. If someone manages to call to get a file, they can get a file that another user set. And we actually show this in our insecure reflection and our insecure deserialization videos. So this being a static is particularly dangerous. It's an especially pernicious vulnerability. And it's also an easy thing to fix because all they have to do is remove static in this particular case. This is something I've seen in the wild many times, many times. And I have seen it cause denial of service conditions in environments, but I've also seen it cause access control violations, just like what we were describing. And on top of that, I've seen it cause really wonky bugs that people for years couldn't find and couldn't fix. And it's literally as simple as unqualified static access. That's simple. That's simple. So our next one is the continue is unnecessary as the last statement in a loop. And I mentioned we would get back to this when we were looking at the super secret BLO method. This is actually a big vulnerability. This particular vulnerability is an interesting vulnerability. They didn't mean to do a continue. This continue means that during our check, trying to do reflection, if I have two methods with the same name and that both take in one parameter, because that's what this code does here, right? So this code grabs all the methods and it gets them based on their name. The next thing that it winds up doing is it checks to see how many parameters that method accepts. So long as it only accepts one, then it's going to check. It will check next the parameter type. And what it is going to attempt to do is convert that parameter into the desired type. If it can do that conversion, then it will invoke the method. It will then continue, which means they do this all over again. So our invocation can occur on more than one method. The developer intended one method to execute. The user intends one method to execute. This code allows multiple methods to execute. To give an example, let's say we have a method called setID. And setID accepts number, long, and integer. And the user passes in 32. And it claims 32, the user claims 32 is an integer. Integer is both an integer and a number. Both of those methods will execute. Now, it could be that it's okay. I mean, it's not great because we set this ID twice, or it could be that one of those two set IDs does something very different and something very undesirable. And so now we're calling both methods with one invocation and something really, really bad happens. That is where this bug becomes a real big deal. The other place this bug becomes a big deal is obviously the number of invocations simply isn't going to match the intended results. From a digital forensics incident response perspective, I can't actually tell necessarily which code was executed in this particular case, which code the attackers were exploiting, not without walking through all the code in a very, very painful process to try to figure that out. So this is a big deal. This is a huge deal to us as security professionals, but it's also uncovering a really simple bug. And again, it's all thanks to the code inspection. So the last example we're going to do with the super vulnerable Java application is an incredibly complicated example. Access static member via instance reference. This tells us that file is static from file VO. This is actually tied to what we were looking at a minute ago, where it was telling us that we had this static file VO that was not being properly called to because we didn't have file VO.file. Same thing, but a different way of telling us about this vulnerability, a different way of identifying to us that we have a static that we are referencing in a non-static context. And when we look at this, the first thing is you probably would be a little confused. You might notice when you hover over this private static at nullable string file, and then you go, oh, this shouldn't be static. And since it's static, the other finding you'll have is right here, equals, it says equals called on itself. That is because left file and right file point to the same static. So they're the same exact object. So we've had a bunch of different warnings that, hey, you have this static here that you don't mean to be a static, that you, developer, clearly don't think is a static. but it is. But we look at this code, and so we figured out, okay. This is static. But there's one more thing. We need to actually examine the whole code, because you look at this code and you say, okay, well, I understand the real problem. What they're trying to do in this, because we always want to understand what they're trying to do, is they're trying to take two separate file VOs. I mean, it says right here, take two file VO instances, merge the data using the following rules, and it gives these different rules here. So we look at it, we say, okay, objects is null, left, right. All right, so if left is null, return right. If right is null, return left. That's all simple. But there's something else. And we do mention it here in these notes. We also mention it here. The problem that we have going on here is the user expects to get a new file VO. We don't return the new file VO. We return left or right. But that's only if right or left is null. And that's a vulnerability. And that's an incredibly subtle vulnerability. It's also a bug. Because if any code that calls to this, so looking at either of these two codes, if any of these do not realize that what they're getting is very much a mutable original instance, they may modify this file VO inside this collection of file VOs and muck it up. And when they muck it up, if we talk insecure deserialization, insecure reflection, and I'm a malicious attacker, and I'm using files BLO get file to grab files, I'm also using it to modify the files, and I can use the corresponding gateway then to modify en masse all of these files that I'm not supposed to have access to, all of these records that I'm not supposed to have access to, because the merge functionality is not properly constructed. And that is what we're talking about right here. So this is one of those incredibly subtle bugs, because this is promising that I will get a new independent file VO, and I am not getting a new independent file VO. So I have the possibility of creating race conditions. I have the possibility of creating deadlock and starvation and all of these other bad things. But I also have the possibility of access control violations. I also have the possibility of people doing incredibly harmful things, all because I'm not returning a new file VO, all because I'm not properly merging, and all because I'm giving them an already in use object that I don't own, that someone else has created. And rather than give them a new one, I'm giving them a reference to an existing one. With that, this is the end of this presentation. I'm sorry that it was extremely long. Hopefully this was useful. You get a lot of really interesting things out of this. Unfortunately, as you can see, there are far too many things for us to go over in 1, 2, 3, probably even 4 videos. This is an incredibly in-depth, incredibly complicated topic. However, as you can see, just these basic warnings that the IDEs are giving us can do a lot and can go really far in helping us find problematic code, helping us find vulnerable code, helping us find issues that we should be exploring as security professionals. And it also lets us do a favor of finding any bugs and things of that nature. This is actually my go-to method for whenever I do any kind of code review. This is where I start, because it tells me the code that I'd want to look at the most. And we've seen already just from this, there are areas, there are classes, there are pathways that I would want to focus a lot of time on that was discovered through this. This is a small code set, and even with really large code sets, this actually makes it very easy to get quick, easy, clean, clear wins that developers won't complain about, and that developers will actually oftentimes love. It also gives you the opportunity to educate them and just show off your brilliance, especially when it comes to matters of heap management and things of that nature.
This is our time. I'm Ranu.
I'm Duran.
And if you haven't already, please like, comment, and subscribe to our channel for more episodes like this one. Until the next time.
Have fun.